All right, let's get started. Welcome to the advanced 400 level webinar on JSON and XML data sources, as well as XPath. Just a quick heads up, I'm a little under the weather, so I do apologize in advance for any sniffling or nose blowing. In this webinar, we cover how to do more advanced XPath, including multiple XPath conditions, unusual data structures, and how to use Klipfolio functions and variables inside the XPath itself. This webinar is a sequel to the beginner 300 level webinar, and we assume that you know the topics that were covered there, which are the basics of how JSON and XML data sources work, as well as how to use basic XPath. There are many examples of how to use XPath specifically within Klipfolio functions as well. If you're a newcomer to JSON or XML, this might not be for you, and you might want to check out the 300 level recording either on our YouTube channel or by asking us for a recording at support@klipfolio.com. I'm going to jump into my sample clip here. In the last webinar, we talked briefly about the Klipfolio knowledge base article on XPath. Even if you are not a beginner to XPath and fully familiar with the 300 level webinar, you may want to keep this article handy, as it has many useful examples and goes over functions in detail. Let's take a look now. This includes a brief overview of some of the XPath functions that we can use, including the contains, count, and last XPath functions, as well as the special Klipfolio KF element add function. The KF element add section in particular is very useful for those who don't use the function very often. You can find this article online at support.klipfolio.com. Let's now jump back into the sample clip. In the beginner webinar, we talk about how to add conditions to XPath expressions using the square braces. For example, if we take a look at the sample restaurant data source, we'll see that we have a list of 5 reservations. And again, we can expand every level of the XPath or every level of the XPath hierarchy by clicking on a node and see what's underneath it. If we wanted to get the names of people who have booked reservations for more than 2 people, we could do this by adding a condition to our XPath to check that the people node is greater than 2. So let's start off with reservations/name. Now we're going to add the condition at the reservations level that the people node is greater than 2, just like this, inside of our square braces. Oops, sorry. Wrong spot. Going to put that here. Do that. And as you can see, we get the names of the 2 people who have booked reservations for more than 2 people. If we wanted to check for reservations at 11 a.m., we could do that as well. And you see we got Mike, who's the only person who's booked a reservation at 11 a.m. However, what if we wanted to apply more than one condition to an XPath? There are 2 ways of doing this, but for this example, we're going to use a data source that is a bit more complex. Let's go to LinkedIn. This data source is from LinkedIn, a popular service, and as you can see, it's a little more complicated than what we were working with before. It is a list of people, including with each person having multiple elements like ID and first name. You can apply conditions at each level of your XPath with separate braces. So for example, let's start by getting the country code of all indices. Just delete that here. This gives us the country code for all of our invoices. However, what if we only wanted to get the country codes where the name of the location is Toronto, Greater Canada, and the industry is marketing and advertising? You can apply one condition at the person level and another condition at the location level. Let's do this now. First, we apply the marketing and advertising to the industry level. That's going to be person. Then, at the location, we add the condition that the name is Toronto, Canada area. And again, we always add our conditions inside of square braces. And you can see in our table that we're now only getting the country code for Canada, CA. This makes sense as we're filtering to only look at Toronto, which is inside of Canada. Another way of applying multiple conditions is multiple at each level. You can filter for things that match more than one condition, or objects that match any of the conditions. To filter for an object that matches condition A and condition B, you can use the AND function. To filter for an object that matches condition A or condition B, we can use the OR function. For this example, let's take a look at an example from another service. This is a zero data source, which is also a popular service that Klipfolio connects to. This data source in particular is a list of invoices along with their information. Let's say we wanted to get the total value of all the invoices where the status is voided and the type is ACC paid, status being here and type being here. Then wrap that in the Klipfolio sum function to get the total. Let's start off with the sum in the total node without any filtering. Start off with our sum function. And then inside of that, we're just going to click on the total value. Next, let's apply the two conditions to the invoice level using the AND function. So it's going to be invoice, and then we're going to have our square brackets to indicate a condition. First condition is that type is equal to ACC pay, all in capitals. And the second condition is added with the word and that's that the status is equal to voided. Again, also all in capitals. Now, something that's very important for XPath is that it is case sensitive. So if you have something that's all capitals, you have to make sure that you enter it the same way inside of your XPath. As you can see, this value is a lot lower and contains many less entries than there are total invoices in the file. So if we scroll to the bottom of our data source here, we can see that there are a total of over 5,000 invoices. However, if we evaluate what we get from our XPath, we're getting just 137 items. This means that only 137 items from our 5,000 match the filtering criteria we have applied to the invoice level. Now let's try the OR function instead of the AND function. We will be grabbing any of the total values where the type is ACC pay or the status is voided. So this is a fairly quick fix for this case. All we have to do, double click on the word, replace AND with OR. Now right away, we can see a pretty large difference in our table column values. Firstly, we go from about 12,000 to almost 490,000. And if we evaluate the number of elements, we go from 137 in our previous case to over 4,000 that match this set of criteria. This is expected behavior, as we are now expanding what our filter would catch. You can add many more conditions as well, and even combine ANDs and ORs together. Let's say we wanted to get all the totals where the status is voided, or both the type is ACC pay and the total tax is more than $1,000. We can see the total tax is another node at the same level. We can add in the splitting of condition sections by using brackets around the part that we want to isolate. So for our example, what we are going to do is have the two AND conditions inside of the brackets and then the OR outside of the brackets. So first, we start with the brackets around the type condition. This isolates this from the status condition. Then we add the other AND condition, which is that the total tax node is greater than 1,000. And again, we do this using the AND function. And And we can see the change in our table column as the number drops drastically. There are some times where what we want to get is not based on the value or name of a node, but whether or not the node even exists. In this case, you can't make your condition using the equals, not equals, greater than, or contains operators. However, the way to do this is actually much simpler, as all you need to do is add the name of the child node inside of the square brackets with no other operators. We can see an example of this in our sample restaurant data that we used before. When we open up the reservations, we can see that only 3 of them have names: Mike, Joe, and Tyrion. What if we want to get the number of people for the reservations that have names attached to them and disregard the number of people for reservations without names? Firstly, we click on the people node in the reservations. Then, at the reservations level, we just add the same node inside of the square brackets. I'm sorry, the name node inside of the square brackets. What this does is this gets only the reservations that contain, underneath that, the name node. This would exclude items 3, items 4, and just items 3 and 4. And then we get only the 3 people nodes for reservations with the name. We're going to switch gears here and talk about another concept in XPath, which is how to go up, down, or sideways between levels. What I mean by this is, each object or array in JSON or XML can have a child node, which is level underneath. For instance, we're going to take a look at the contact of one of our invoices and expand it out, again, in our XML data source from 0. So here we see our contact. In this situation, contact would be a child of its parent, which is invoice. If we dig into the contact object, we can see that contact ID is a child of its parent node, contact. However, the contact ID is also a sibling of the name of the contact, which means that they're on the same level in the object hierarchy. In XPath, we can move up or down levels and grab siblings. However, we can also use this inside of our conditions. Let's just start with the basics. Say we are at the contact ID node. Then we wrap in the name function. And again, if you tuned into our last webinar, the name function gives you the value on the left-hand side, which is in bold here, as opposed to the value, which is on the right-hand side. So this will, of course, just give us contact ID, because we are finding the name where the name is equal to contact ID. We then move up a level by adding the slash at the end of our XPath and then the 2 dots. This special syntax moves up a level in the hierarchy, as opposed to just a slash, which moves a level down the hierarchy. So as you can see, we are now getting the name of the level above it, which is just contact. Let's do a more useful example where we actually get the value of something. We're going to start off at the invoice level and move up 2 levels to get the provider name. You can see that the provider name is at the top here, inside of the response. So this first part moves us to the invoices level. Oh, I'm sorry. We're first going to get just our invoice, and we can get that by clicking on any of the nodes inside of the invoice and then removing the last part. So we're going to click on, for example, date. We're just going to remove the date at the end here. We then add the slash and 2 dots, followed by another slash and 2 dots, then another slash, and the node we are looking for, which is provider name. Don't worry, I'll walk you through this part. So the first part moves us up to the invoices level, and we do that again with the slash and the dot dot. So we then move from invoice to invoices. Then we add another slash and 2 dots to get to the top level, which is response. So we're now inside of this node here. We then add another slash to go down inside of the response and get the final node we are looking for, which is provider name. So we add a slash provider name. This gives us the name Klipfolio, and if you look at our data, this is the correct value. Let's say we wanted to find something that instead grab its sibling instead of its parent or child, like we have done in our previous examples. So for example, we started the status node inside of our invoice. We can then get the value or name of one of its siblings using the preceding sibling or following sibling functions. These find a name or value at the same level of the XPath that we are already looking at. The preceding sibling is used to find values that are before the node you are looking at, and the following sibling is used to find values in a node after the one you're looking at. Here's where there is a key difference between XML and JSON. In XML, a node is a preceding sibling if it appears in the data before the one you are at, and following if it appears in the data after. In JSON, it is preceding if the name is alphabetically before the one you are looking at, and following if it is alphabetically after. The location of the nodes in JSON data is actually relevant in this case. So if we wanted to get the line amount types next to the status, in JSON, it would be a preceding sibling because L is the first letter, and that comes before S, which is the first letter of status. But in XML, this would be a following sibling because we see it directly after that inside the data. The nodes do not need to be directly beside each other, like in this example, for this to work, only on the same level. Since this is an XML file, we would do the following sibling to get line amount types. What we do is add a slash to the end of the XPath, followed by the word following dash sibling, then 2 full colons, then the node in question. So let's go ahead and do that now. So we're following dash sibling, 2 full colons, and then the name of the node in question, which is line amount types. And voila. Let's do a quick example with the preceding sibling as well. In this case, let's use date. We can scroll up and we can see our date is this node here. So again, it's preceding sibling, 2 full colons, then the node in question. And we get the date node. You can actually move up, down, or sideways inside of your conditions as well. What we'll do here is get the total value where the contact name is Broadwave. First, we start at the total node. Then, we add a condition inside of the invoice node using our square brackets. Now, the condition we are applying here is actually that we're going to go down into the contact slash name and check if the value there is Broadwave. So we're going to start with contact slash name is equal to Broadwave, and again, case sensitive. This gets me the total value of all the invoices where the contact's name is Broadwave. Finally, the last XPath function we're going to be talking about is the contains function. The contains function is arguably the most useful of the Klipfolio XPath functions, as what it does is check if a name or value contains a specific string or text, a specific text string or number. You can use it as a condition in your XPath to filter, looking for names or values that contain something unique. A great example where we could use this would be inside of a Facebook data source. Let's take a quick look at that here. If we check out what this looks like and open up the values, we can see that we are getting information about the likes of a Facebook page. However, this is segregated based on age and gender. What if we wanted to only get the values for males or females? If we wanted to get the values for males only, what we would have to do is filter with the condition that the name on the left-hand side here contains the capital letter M. So first of all, we start at the values. Now, notice how in our XPath it is giving us the 3 sets of values, but only for the male 35 to 44 age category. And this is because each one of these values here on the left-hand side has a unique name. If we want to get all the values pertaining to males, we would have to use the wildcard as well. So our first step is to replace the male 25 to 34 category here with the wildcard star character. And finally, we add the condition that the name contains the letter capital M. The contains function is on the outside. Its first parameter would be the name function, and what we are looking for is the string with the capital letter M in it. So again, always the square brackets for condition, then we have contains, then brackets. Our first parameter is name, and our second parameter is what we're looking for, which in this case is the letter M inside string quotes. And there we have it. This gets us all the values for Facebook likes for the male gender. Finally, we come to our last and perhaps most powerful example of the webinar. In the next steps, we're going to detail how to use a Klipfolio function or variable directly inside of the XPath itself using the Datasource function. For this example, we are using our LinkedIn data source again. What we have in the table is currently pretty simple. In the first column, we have the headline of each person in the data. In the second column, we have the URL of each person's profile picture. In the properties panel of our second column, we have our format set to image URL so that we can see the actual picture itself and not the test link. What we're going to do here is implement a filter to get only the headline and profile picture of the user selected in the user input control at the top. Let's take a quick look at this in the input control. In the values, we have something that is unique to each person. In this case, that's the person's profile ID. In the labels, we have the first and last name stitched together using the concat function, which we'll talk a little bit more about in a minute. And in the properties panel of our user input control, we are setting it to use the variable user ID. So, if we look at our first column, we need to modify the XPath being used there. We need to use this to point to the variable specifically inside the XPath. So the first thing we do is we add the Datasource function. I'm just going to expand my formula bar out a little bit more. And Datasource. This function is used whenever we need to point to something in a data source that is dependent on a variable or function in Klipfolio. We can also point to a specific data source as well. The Datasource function is super useful in allowing you to look at data that is not necessarily always going to be in the same place. The first parameter is actually the ID of the data source we want to be pointing to. We can find this ID by clicking on the I next to the name of the data source in the bottom panel. So this is our LinkedIn connections. Click on the I here. Then the ID is found as the long string of characters at the end of the URL. We can double click on that and copy it back here. We then put it inside of quotation marks for our first parameter. We are now pointing to the LinkedIn data source. The next part is a little tricky, and it involves stitching together the XPath we need to use with the concat function. The concat function is used to combine multiple strings together into one string. This can include functions or variables like we need. For the starting XPath, we will just copy what we have currently underneath. Make sure that when you do this, you exclude the semicolon at the end and the @ symbol at the beginning. And again, because this is a string, we're going to put it inside of quotation marks. And there we go. We can now remove this part here. Then I will need to add in the condition that we're looking at. The condition is done at the person level. It is checking that the ID is equal to the variable user ID. For now, just use the word user ID as a placeholder, as we are about to replace it with the actual Klipfolio function. So it's going to be person, and as always, we have square braces for our condition, where ID is equal to user ID. And as always, for a variable in Klipfolio, we have the $sign to indicate that it's a variable. Now, to introduce the actual variable. First, immediately surrounding the user ID, put quotation marks and separate the sections with commas. Then, replace the user ID text with the actual Klipfolio variable, user ID. Now, in this case, this has already happened because I had the $sign symbol inside of my XPath. So when I took it out, it interpreted it as the variable instead of the text. You now have your full XPath. You can evaluate what it would look like using the concat function. Note here that inside of the person node, the ID is looking at the actual variable value of the ID that we have currently selected. So if I evaluate the user ID, that's the value that was popping up in my concat function. We can then use this similar formula in the profile picture column, but just replace the headline with the picture URL. All I'm going to do is copy and paste the entire thing here. Change headline to picture URL. And there we go. As we change the variable value, the table updates live. So let's take a look at Matthew Iman, and we can see that the headline and profile picture are matching his name. Well, that's all for today, and thanks for tuning in. I hope you enjoyed the webinar, and if you have any questions, I have a few minutes to stick around.